but I got to get back to this
we're starting a new recording for this experiment. Scale is shifting around.
Go ahead to your software and let's just wait 30 seconds. Go into the software, hit null.
You mean get on top and I should zero it out?
Oh, that's right. It's manual. Sorry, never mind. Just leave it as it is.
No, I'll zero it out. That's a good idea.
It's going to shift too much, I think. Well, we'll see. We've got to really zoom into that sample and watch that son of a bitch closely, because if that thing moves when the magnet gets turned on, and it shouldn't, because there should be no magnetic element in there, that thing should stay pretty much exactly where it's at when the magnets and the RF get turned down. They shouldn't shift.
The magnet right now.
I'm watching it real closely.
Turning it on. 3, 2, 1. It's going up. At full power. Okay, so there was a
I didn't
rise.
see it visibly move.
I didn't see anything.
But
I did see the reading change.
The reading
Shut it
change
off.
a little bit.
Shut it off.
Okay, shutting it off. 3, 2, 1. It's off. Dropping, dropping.
So it jumped and then dropped.
I'm seeing that. Mark, I need you to pin your display.
To do what?
Pin your display.
What do you mean tin my display?
No, pinned, as in when we talk, our fake icons show up. I want you to focus your display as the primary presentation.
It is that way.
It's, well, okay, right now it does seem to be working correct. Yeah, for some reason when I was talking before, it overrode that, but it's working now, so we're good.
Check, override.
Yeah, yours is overriding it, Jacob. I don't know why.
Jacob, that's a setting in Jeremiah in your phone. The way you're in the your
hide
setting
self-view.
Oh, so I have to actually choose your display and click pin.
Yes.
Yeah, that worked for me. All right, yeah, you're full screen now.
You got it?
I actually don't have that option. I cannot click on your screen and hit pin. That's weird. Yeah, I literally have no option to click pin. That's not available in my cell phone.
It's a right click on desktop, and it'd be like a quick press, but you press and hold. See if you get an option on the screen.
Let me see if I do that. Ha! You were right. I had to hold my finger on my display. Thank you. That was a completely hidden option, and I would have never found that, Jacob.
You got it?
Yeah, Jacob just totally highlighted how to do it. I guess the desktop translation of clicking with your
right click on a smartphone
clicks on the cell phone as holding your finger over the display that you want to pin.
Okay, you ready?
Yep, let's go.
Okay, I'm turning the magnet on.
Okay, well that's an increase of 7.
I got a 10.1 roughly.
Yeah, 0.15 thereabouts.
There was a point where it dropped back down to 0. That was weird. I'm turning it off now.
Why would the magnet be?
So yeah, it did it again. It jumped and dropped.
Yeah, that's the second time. Yeah, it jumps up, Mark. So at the end, you turn your magnet on, you get a major increase of between 600 to 700 milligrams thereabouts. Sometimes more. It's even jumped up to 1 milligram. Then when you shut it off, it jumps up to 1.6 or 1.7 milligrams, and then it comes back to its rest rate.
Interesting.
So I jumped up to 0.2 or so.
Let's try that again. I'm turning it on in 3, 2, 1.
Watch your numbers this time.
It's on.
Watch your numbers.
Okay.
You see that? When you okay. Oh, leave it on. Yeah, leave it on.
This is larger now.
It's still going up. Leave it on until it stops climbing.
Okay.
I'm not seeing any movement on the sample either.
I'm not either, but I am seeing that number climb. And again, that type of scale, the actual movement to generate a differential reading is nanometers. So we'll never see it visibly. Okay, I know this is going to probably continue to climb, and I don't understand why. Go ahead and shut it off.
Oh, it just dropped.
Wait till it reads. Wait until it reads 2700. So, and then shut it off right now. Shut off.
Turning it off. Turning off. It's
Jump again. Wow.
Look how high it went, Mark. Look, you see how it went to 0.4?
Oh, 1 second. Let me get that one.
It jumped way up.
So now, now your zero's higher now. So it looks like you some sort of history.
And it's going to drop down. It's going to drop down too. Watch it just continuously decline. It's not declining. What the hell is going on?
Weird. Because it was dropping down to near zero.
Jeez. What do you think is going on here, Jacob?
I have no freaking clue.
This is weird as hell to me too. I've not seen this kind of behavior before. And considering this, the physical measurement device is outside the Faraday chamber, you know, on the top. It's physically outside.
Jeremiah, look, at 2700 is when I turned it off. As it was dropping, it rose to...
Right, it consistently rises about a tenth or so.
Yeah, the second you shut it off, you get a major spike.
And it drops off.
Over 25% on your spike dude. And it only lasts for a couple of samples, 2 seconds to 3 seconds thereabouts, because these are 1 sample a second. Is that? No, these are, this is 5 samples a second? How many? Are you 0.5 seconds, 0.2 seconds, 0.1 seconds? What do you set?
I'm not sure. I think it's a couple times a second, probably 3
Yeah, 2 or 3.
Yeah, it looks like 200 milliseconds, or 5 times a second. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5.
Okay, magnet's going on. 3, 2, 1. Magnet is on.
So it dropped and then now rose. Okay.
Basically, when you turn it on, it drops and then goes up.
It does the inverse
thing. Off,
yeah.
it goes up and then goes down. It does the inverse. Yeah.
There's got to be a reasonable explanation for that.
Your floor.
I don't know what that is.
Eddy currents in a changing magnetic field with the geometry that we have.
What do you guys think that this is a lens law style repulsion attraction, just like any kind of induction heater or something like that?
Yeah, it is. It's currents being induced inside the aluminum because of the changing magnetic field.
Hey Mark, do us a favor, but go ahead and hit record on your screen.
I'm recording this.
Okay, grab your large magnet. I need you to go in there and wave your magnet past that thing at a distance close enough where your magnet doesn't rip your fingers off and cram them against the steel. I just want you to wave that thing past the sample and see if,
I'm not doing that. It's too dangerous. But it's definitely being attracted by magnets, especially when you change them. But now it's stable at that point. So let's turn on the RF and see what happens.
Oh, that's right. We haven't turned on the RF yet.
So why is your zero now at 0.3 roughly? Before it was, a milligram or so at the beginning.
My guess is that he had to adjust and fiddle with the RF cable initially to get it to that
position. In 3, 2, 1, on. Yeah, there was a drop there.
Big time. 500 milligrams thereabouts. Well, about 440 milligrams.
Okay, turning it off in 3, 2, 1.
Sorry, 44 point something milligrams, not 440.
It's rising back up slowly. It's rising back up.
I'm not seeing the inverse jump each time you switch it. It seems to be.
No, not for the. We're not getting the inverse jump for the RF. The inverse jump was from the magnet.
Oh, okay.
By the way, when you say you flip it on, is that flipped on with a modulation on it, or is that just flipped on CW?
That's flipped on CW right now. Should we go for modulation?
Yeah, please.
What frequency of modulation?
4 hertz.
4 hertz, 4 times a second?
Or 1 hertz. I'm fine with either of those.
Up to 4 hertz. Modulating, turning it on in 3, 2, 1.
Let's watch this for a minute. And why did it drop so much during the time where you were setting it up?
That's with an error right there. I don't think anything's going on, or at least it's stabilized.
Yeah, I shut it off.
Okay, shutting the RF off in 3, 2, 1.
All right, do me a quick favor. Put your hand behind there, grab the RF cable that's coming out of that SIG gen, and I just want you to wiggle it left, right, up, down by at least, quarter inch. I'm not asking you to wrench on it. Just fluctuate it around a little bit. I just want to see kind of. I don't want you to shake it. I want you to just simply press on it and hold it for about 1 second in each position. I just want to see if there's something.
About this one over here?
Whatever your RF cable feed that goes into the chamber is, I just want you to move the cable from the outside where you're positioned, so
that
that
would
we can.
Destroy everything. You don't want to touch that.
You can't move it by a quarter inch or an eighth inch. What I want to eliminate is that your button pressing and your physical motion of the equipment is not fucking it up. Like, imagine that you push on that thing, the cable is so stiff that it somehow, conveys that push of a button on the front face.
I'm using these LED lights over here to counteract that. So it's being squeezed together. It's not one thing moving, it's more of a squeeze. Here, RF on, here, look how I'm doing it. So 2 fingers, squeeze them together. This thing weighs also over 100 pounds. I don't think it's moving.
Maybe the readings are just in.
RF on, and then on this side, I push them together and turn them on off. RF off in 3, 2, 1. Oh yeah, it's doing that same thing. It drops and then it rises again.
There's a smaller magnitude there for the RF,
Yeah,
but the field switching was more significant.
It's doing the same thing, but to a lesser magnitude. Maybe to the magnitude of change, though, it's the same.
It could be nonlinear entirely too. It could be that
I think the frequency that you pulse at needs to be higher than 4 hertz. They said 5 milliseconds. How many hertz is 5 milliseconds? Isn't that 20 hertz?
I'll check just to make sure.
A 5 millisecond pulse. It's either 20 or 200. I don't remember. So a microsecond would be 200. So it's probably 20 hertz.
200 hertz, maybe? Is that right?
I'm just putting it into the calculator. 5 milliseconds equals, according to a calculator, 200 hertz.
200 hertz. Okay, that's what I had before.
You're doing frequency modulation, or is it?
Yeah, all it's doing is it's turning the drive signal on and off, hard cut off. Same way DRS STC produces.
I turned it up to a stronger setting now. Now it's doing negative 15 dB. So 3, 2, 1.
Immediate 10.1 milligram loss. And then it's continuing to drop.
Oh, it's dropping fast.
Holy shit, what's going on? Leave it on. Dude, tweak with the frequency now.
No.
Okay, that's
What the hell is that?
Okay, turning it off.
Tweak with the frequency.
What?
No, don't shut it off. Tweak. Fuck with the frequency.
The frequency itself?
Are you seeing these numbers?
Yeah, it's fluctuating quite rapidly both ways.
I mean,
now.
it was a lot more than before.
Yep.
You almost got negative there. You got down to 0.016.
That's changing very fast.
Dude, that is a lot. Okay, I'm sorry, but I know where that scale is, and I understand what that scale is. How is that happening?
So it's just, what, a nylon string that's hanging down from the scale?
Okay,
Yeah,
this
that's
is over a gram of difference.
Holy shit, where are we at?
Wow.
Holy shit, dude, I think this might be it.
I'm turning off the RF in 3, 2, 1. It's off now.
Alzofon said the weight went up before it went down, and so did PNN, and so did Perez.
This is so weird. It keeps on going
Well, now
up.
it's just, yeah.
They all said the same thing. They said the weight goes up after you shut off the power, and then after a period of time that's approximately twice as long to 4 times as long as the run time, it'll drop it back down.
Okay.
But what is going on here? I don't
That's 2
know.
grams difference.
So what is on right now? Your RF is off? It's just your field?
Just the magnetic field. Should we turn the magnetic field off too?
Turn everything off, yeah. See what happens.
It looks like it's stabilized at 2.03 thereabouts. So go ahead, shut off the magnetic field now. We've got that data.
Okay, 3, 2, 1. Off.
What?
Something is seriously going on here. If that ferrofluid is genuinely wiped off that container,
yeah, we cleaned it off pretty well, right?
Like, it looked clean to me. Is there any other magnetic elements on that thing? Would you do me a favor, Mark? Take a powerful and small magnet. I just want you to see if there's anything magnetic on that chassis. Could you please try to just find it, probe it, if there's anything magnetic on that chassis? Because
if you have a moving magnetic field, you're going to move that sample around.
yeah, but if you're injecting that moving magnetic field with RF, that's significant. So
it's stabilized now.
Okay, I'm going to turn the magnet on again. 3, 2, 1.
Why is it a higher level? I don't understand that.
the cable has got to be changing. It's what do you call it? It's colic.
What? I never heard of that.
Okay, I'm going to turn the RF.
It means it wants to stay in the same shape it was.
I'm going to turn the RF on in 3, 2, 1.
Man, this is confusing. Are you on modulation right now?
Yeah.
He turns it on the first time, it's fucking amazing. Turns it on the second time.
Yeah, we got to repeat that first run there somehow.
Did you do anything different, Mark, between this run and the one that you just did previously to this one? About 5 minutes ago? Whoa, there it goes.
What'd you do?
What did you do? What did you do, Mark?
I was just setting the settings on this thing.
Are you looking at
Did you
your
bump any
screen?
cables?
Oh, it's moving. It moved to the side.
Yeah, it's moving a lot. It's going up a lot.
Okay, turning the RF off.
Oh man, it's still going. Maybe you don't want to shut it off yet.
Is that making it go, or is that something else that's doing that?
Oh, it's going up. Well, let's just find out how extreme this thing is going to go. Maybe if it's heat, it'll go really far, and then when you shut it off, instead of being stable like it was last time, it'll start to decay real quickly. Let's find out if it's cable heat. How many watts are going through that coax?
I have no idea. Up to 200 are coming out of this thing, and it's probably not running at full power, and maybe 10 watts. I don't know.
Wow. I mean, if this keeps on going. Okay, there we go. It's stabilized.
I do know
and,
power is coming through because when I turn it off, I'm getting a signal on an antenna that's hanging up there.
3.65.
I don't understand why does the floor keep increasing?
2, 1. RF is on.
The cable itself has got to be warming up from the RF power being pumped through it.
So it's just the stiffness from the cable?
Pulsing and turning on in 3, 2,
Yeah,
1,
that's what I'm
on.
estimating here.
The pulsing just went on. When I turned the pulsing on, it really changed it fast. Pulsing at 200 hertz. Now it's going back and forth now. It's dropping.
I wonder if you do some tests with just the coax itself, like energizing the coax, like outside of the field independently, just to get an idea of how it behaves under these frequencies.
It's a really good idea.
Okay. RF off in 3, 2, 1. Magnetic field off in 3, 2, 1.
As usual, goes way the hell up. And then right about now it should drop.
Drop
Okay, here
back
we
down.
go.
There you go. That's cool.
It's consistent.
It's been doing that consistently, yeah.
Yeah, you're building up some residual stress somewhere with these
Okay, I'm
cycles.
gonna turn the RF on right now. Let's see what happens. 3, 2, 1. Oh, it's dropping pretty rapidly. Oh wow, it just dropped a lot. Now it went up, down again, bouncing around. Constant power now.
Let's see. Are you making contact with the side now?
Yeah, it might be.
How did that happen?
RF off.
I mean, if the cables or the coaxes are getting stressed out by the power input, and it might be
I think we have our
flexing.
answer then.
I'll get the thermal camera to take a view at it.
Oh yeah, please do. I'm pretty sure we have our answer. That thing shifted. The cable is suspended by gravity alone. If it went right, left, up, or down, and it's entirely non-magnetic, it is clearly the coax producing this problem.
Yeah, that makes sense. So you're getting a moment about the string, and so you've got all that length of coax behind it, flexing in one direction. So you're gonna rotate into the either side of the magnet wall.
Though. I think we saw lots of movement before the coax moved. Let's have to review the video.
Well, I mean, I'm saying you're getting a definite deflection left and right. You're not getting like a vertical motion, I guess.
But a different twist in position could easily cause that too.
Yeah, I'm thinking you're getting a moment due to your cable. That's my guess.
Isolator went up to like 40 degrees centigrade. Go inside, get some measurements of the coax.
Because now your cable's in a different resting position, and that's why you're getting a different value on your readout.
I hate to say it, but this test is invalid.
Oh, it's hot.
I want this to be good, but it's
I mean,
not.
that was interesting though. I mean that.
It was. I mean, we all learned something today. We learned how much we cannot rely on coax to be a reliable source of continuous tension. And that we must have a flexible coupling point somewhere along the line to eliminate the coaxial reshaping problem.
Yeah, you're just getting a physical response from the cable due to the input.
That thermal only, and that's not exciting.
The coax is hot.
Oh well.
Coax is hot, yes.
Yeah, that explains all the readings, Mark.
So we need a better way to do this. I'm not sure if it explains all the readings because
I'm not 100% sold on that. I mean, there's something going on, but I think a lot of the error is due to the cable right now.
we should really watch a replay of what we just did.